another commodity. So that, of course, depends on the relative price of these two things. Reese's could be more or less expensive than Hershey's, so the total expenditure on Reese's is simply going to be the price per unit of Reese's times the number of Reese's you consumed. You add to that the number of Hershey's consumed or purchased times the price of Hershey's that is advertised at the store. So the sum between expenditure on Reese's and Hershey's has to add up exactly to income. We could also look at this as a weak inequality where you're consuming less than or equal to what you're spending on Hershey's sorry, where you're consuming less than or equal to the number of dollars you have for income, but I'm not going to worry about that for now. Okay, we could talk about that later. All right. Oh, I have to draw again. I'm terrified. I'm joking. I can handle it. Okay. So let's use an example here. Right? I always like to motivate these new concepts by just giving you an example with a couple of numbers. Let's then draw it, and then after we're done drawing it, what we can do is we can talk about it, and then we'll get to the least favorite part of this whole thing, which is using it, showing what the math version of this looks like. So if you have $80 to spend, Y is 80. If Reese's, PR, is $2, and the price of Hershey's is $4, so PH is 4. If you consume 20 bags of Reese's and 0 bags of Hershey's, you are consuming 20 bags of Reese's at $2 a bag, spending $40 and 0 on Hershey's. So you're spending $40, so you have $40 left over, right? If you are consuming 10 Reese's, so 10 times 2 is 20, plus 25 times 4, you're doing something wrong here, right? So 4 times 25 is 100, plus 10 times 2 is 20. You're consuming 120, you only have $80. You have minus $40 left over income. If you're consuming 0 Reese's and 40 Hershey's, Hershey's are $4 a bag. Did I get these switched? Oh, man. You know what this thing did, or I did? $1 for the person that recognizes what's going on here. Do you recognize the marginal utility of Reese's in the right column here? I do. All right. Let's come up with some numbers ourselves. We're crafty. We can figure this out. All right. Here we go. So 20 Reese's, 0 Hershey's. My number is still right here. So 20 Reese's, if they're $2 a bag, we are spending $40 on chocolate. We have $40 of leftover income. If I am consuming 10 bags of Reese's, I'm spending 20 on Reese's, and let's say 15 bags of Hershey's. Okay. So 10 times 2 is 20. 15 times 4 is 60. I'm spending $80. I have 0 units of leftover income. If I'm consuming 0 Reese's and I'm consuming 20 bags of Hershey's, 20 times 4 is $80. Again, I have $0 of leftover income. If I'm consuming 40 bags of Reese's and 0 bags of Hershey's, 40 times 2 is 80, plus 0 times 4 is 0, so I'm consuming $80. Again, I have 0 leftover income. If I'm consuming 10 bags of Reese's and let's say 10 bags of Hershey's, I'm spending 20 plus 40, $60. I have $20 of leftover income. And what else could we do? 10 bags of Reese's and 0 bags of Hershey's, I'm spending $20. I have $60 of leftover income. Okay, I apologize for this table. It was new. I was all excited and then I screwed it up. But hopefully this is clear what's going on here. So what I've got here is I've got 3 bundles where I'm consuming all my income. All right, I'm going to look at these 3 bundles. This bundle right here is a bundle where I'm spending all my money on Reese's. This one here, where are you, is the bundle where I'm spending all my money on Hershey's. So let's plot these 3 bundles where I'm spending all my money on the 2 commodities. Okay, if I spend all my money on Reese's, I can afford 40 Reese's. So this is this point right here. If I spend all my money on Hershey's at 0.20, I can afford 20 bags of Hershey's. The third bundle where I'm spending all my money is 10 and 15. So 10 Reese's, 15 Hershey's, right here. Come on. There you go. I could keep on playing this game. How did he draw a straight line like that? Postcard, that's right. But I could keep on playing this game, right? Pick another point. 10 bags of Hershey's, you're spending $40 on Hershey's, and 20 bags of Reese's, you're spending $40 on Reese's, you're spending all your money. So on this line here, the line that connects 40 Reese's, 0 Hershey's, and 20 Hershey's, 0 Reese's, all of these bundles right here are the possible combinations where you're spending all of your income. This line right here is called the budget constraint. Wow, that's terrible writing. Whoa. I'll get better, I promise. But this is the budget constraint. This is the set of bundles that you can choose to consume, and you're spending all of your income. Well, Max, that's pretty interesting. But again, I'm from Berkeley. What about these puppies right here? Right? Here, there's some money left over. I wouldn't spend all my money. Can I afford these bundles? Yeah, of course you can. Right? So let's plot one. 10, 10. In color. 10, 10. How about 10, 0? 10 Reese's, 0 Hershey's. Right? We could come up with a whole bunch of bundles that we can afford, but where we're not spending all of our income. So this area right here, below the budget constraint, that includes this whole area right here, this red area right here, that's called the opportunity set. Okay? This is called the opportunity set. This is the set of bundles I can afford with my income. The red bundles are ones where I have income left over, and the ones on the actual budget constraint right here are the ones where I'm spending all of my income. Okay? So the frontier of the opportunity set right here, which is the set of bundles where I'm spending all of my income, that we call the budget constraint. The whole triangles of all possible bundles that we can afford, that is called the opportunity set. Well, what about the northeast of this map? What about those bundles? Can I afford those? No, right? So pick any bundle here, 20 Reese's, 15 Hershey's, 15 times 4 is 60, plus 20 times 2 is 40. That's $100. You can't afford it. So the budget constraint maps out the part of the overall possible consumption bundles into the set that you can afford and the set that you can't afford. All right? So this is our characterization of scarcity. You wish you could consume up here, but you can't because you don't have enough income. Scarcity constrains you to possible bundles on or below the budget constraint. So this is how we're going to model scarcity. Okay. there's something cool hidden in the budget constraint. So we all agree that this is the equation for the budget constraint. The total number of dollars of income you have add up to price times the number of Reese's, so the price of Reese's times the number of Reese's, and the price of Hershey's times the number of Hershey's. So expenditure on Reese's and expenditure on Hershey's have to add up to income. Now, I would like to write this down as an equation that actually tells me something meaningful, and you have to trust me that this is important, okay? So what I'm going to do, like they do in real science, I'm going to write an equation where I'm going to express the variable on the y-axis as a function of the variable on the x-axis, right? So y is some function of x. So let's take this budget constraint equation and solve for that, okay? On the y-axis, I have r. So I'm going to take everything that's not r and shove it on the other side. So in order to do that, it's y minus ph times h is equal to pr times r. And then you divide both sides by pr, and you get r is equal to y over PR minus PH over PR times H, which is exactly this lovely expression right here. Now, this looks messy, but one of the equations that everybody likes and everybody understands is what we properly are supposed to call an affine function, but we'll call it a linear function right here, right? Remember this one? Y equals B plus MX, or MX plus B. When I started at Berkeley, I wrote Y equals A plus BX, and somebody raised their hand and said, Professor Alfheimer, I realize you're new to Berkeley, but at Berkeley we write this as Y equals B plus MX. So I'm writing it the Berkeley way. It's the exact same thing. I'm just joking. Picking on somebody from 12 years ago who's incredibly successful now. But what do I have here? This is just the expression for a linear function where b is the intercept on the y-axis and m is the slope of the line, right? So here in this case, y, the dependent variable, is the number of Reese's. So the budget constraint's intercept, this number b right here, is this number right here, y over pr. So what's the intercept of the budget constraint on the y-axis really stand for? It means how many Reese's can I buy if I spend all my money on Reese's, right? In order to figure out if you have $10, how many chocolate bars you can buy in the store, what do? You divide your $10 by the price of chocolate bars, and that gives you the number of chocolate bars you can buy if you blow all of your income on chocolate bars. So that's exactly what this intercept says here. Total income divided by the price of Reese's. This is the total number of Reese's I can buy if I spend all my money on Reese's. Now, we're also interested in the slope, right? So the budget constraint has this nice downward slope right here, meaning as I get more Hershey's, how many fewer Reese's can I buy in order to buy one more Hershey's? Because you have a limited amount of income, so you're going to have to give up the possibility of purchasing some Reese's in order to be able to buy more Hershey's. Well, if you free up one more Reese's, right? You buy one fewer Reese's, how many dollars do you free up? If Reese's are $2 and you buy one less Reese's, how many dollars do you have available right now? 2, right? So how many more Hershey's can you buy? It depends on the price of Hershey's, but you guys already figured out that they're half, twice the price of Reese's, so yes, a half. You guys are smarter than I am. But the point here is the rate at which the person at the 7-Eleven lets you trade in Reese's for more Hershey's simply depends on the relative prices of the two. And by trade in, I don't mean you walking up there with an old crumpled up Snickers bar that has a soda spilled all over it and said, how many Hershey's can I get for it? But you're standing in front of the shelf and you're trying to make a trade-off. You're looking at the prices. At which rate can you convert Reese's into more Hershey's? And that simply depends on the relative prices. So if we look at our budget constraint, the intercept here, this number, not even I am tall enough, 40 right here, that's income divided by the price of Reese's, and the slope of the budget constraint is simply the price ratio of the two goods. That price ratio, or the slope of the budget constraint, has a name. It's a marginal rate of something, right? Much like the marginal rate of substitution was the slope of the indifference curve. It was the rate at which you were willing to substitute between Reese's, the rate at which you're willing to give up Reese's for more Hershey's. This marginal rate of transformation is the ability to transform Reese's into more Hershey's at the store, right? At which rate do they actually let you exchange these? And that marginal rate of transformation, as we just discussed, is simply the slope of the budget constraint, all right? The slope of the budget constraint tells you at what rate can you convert Reese's into more Hershey's. The slope of the indifference curve lets you figure out at which rate do you want to convert Reese's into more Hershey's, right? So they're fundamentally different things that we're going to put together in a second. The rate at which the market lets you exchange or transform one good into the other just depends on the relative ratio of prices. And that's pretty neat. In our case here, it's change of R over change of H is equal to the ratio of prices. If they're 4 and 2, the marginal rate of transformation is -2. Right? That number is constant along a straight line, and it simply depends upon the prices of the two goods, which we assume are fixed. Right? There's no bartering here. There's no all of a sudden something goes in sale halfway through the transaction, or you just take stuff that you weren't supposed to take. None of that here. You pay the price. Prices are exogenously given. We will change that too going forward. Okay. I don't know about this thing. It's even smaller on my screen now. That's exciting. Okay. So what I want to do in my last 9 minutes, and then you get to have lunch and complain about economics all you want, totally fine with me, is I want to put it together, all right? What I mean by putting it all together is I want to put together what people want versus what they actually can buy, right? We are in this business of trying to figure out how individuals make themselves as well off as possible in the face of scarcity. Let me give you a different word for that. The way I look at the world, scarcity is a budget constraint. How well off you are or how happy you are is simply how high of an indifference curve are you on. So to translate making yourself as well off as possible in the world of scarcity into a language that even Max can understand, you would say, dear Professor Alfheimer, I would like to get on the highest indifference curve possible while still consuming a bundle on the budget constraint, right? That's nerd talk for making yourself as happy as possible in a world of scarcity. So what I want to try and figure out is I want to get on the highest possible indifference curve, but still consume a bundle that I can afford given my income and prices. So I'm going to draw this for you in 1 second, but there's a bunch of interesting scenarios that come out of this. For some goods, you consume some of both goods. Reese's and Hershey's, I consume some of both goods. I like them a lot. If we're thinking about Porsche rides, or Porsches, which is a German car, and soy lattes, I drink a lot of soy lattes. I don't consume any Porsches, right? Why? Do you know how much a Porsche is? The one I like is $142,000, 362 cents, including tax and delivery charges. I've built it on their online car configurator. I can't ever drive it because I'm an environmental economist, but even an environmental economist can dream, right? So the point here is we can come up with solutions where you're consuming positive quantities of both goods, or you're just consuming some of one good and none of the other. So we will talk about this, and we can have both types of solutions. So here comes the disastrous drawing. Are you ready for this? I don't know if I am. I got to practice more this weekend. Okay. I'm going to draw my budget constraint, all right? This budget constraint is totally arbitrary. I'm going to look at two goods. They both cost $1. Okay? We agree that this is my budget constraint. Let's say y is 8, px is 1, and py is also 1. On the y-axis, I have a good y. On the x-axis, I have a good x. Doesn't matter what these goods are. They could be Reese's and Hershey's. But I drew the budget constraint. If I spend all my money on good y, I get 8 units. If I spend all my money on good x, I also get 8 units. So this is my budget constraint. Now, other color pen. Here we go. I'm going to draw an indifference curve for max between these two goods. And my indifference curve looks like this. It's a pretty nice looking indifference curve. These goods, y and x from x, are imperfect substitutes. Max is pretty awesome, all right? He's finally can afford a bundle that's exactly on the budget constraint, or he's got 2 bundles on the budget constraint he could be consuming. He could spend all of his income on x and y. Is Max rational? Is Max making himself, by consuming either of these 2 points or any of the bundles on this indifference curve, is he making himself as well off as possible? Why not? Say it. I love it. That's exactly it, right? So I could draw a higher indifference curve. I'm going to ignore the last thing you said because that's like really right, and I want to get us halfway to really right now. Okay, you said draw a higher indifference curve, one that's downward sloping everywhere and doesn't cross the other one. Looks something like this. Whoa, thank you. A Berkeley student just got me on an indifference curve that's higher. I'm now consuming this bundle or this bundle right here. Am I as well off as I could possibly be? You're shaking your head because you've already told me where I should consume. Max, you should consume right here. Well, I wish, right? Is there a single bundle on I4 that intersects the budget constraint? Can I afford I4? No. So what I'm going to do is I'm going to move my indifference curves or figure out the one. I'm going to call it I3. I3 right here shares exactly 1 point with the budget constraint. 1 point and 1 point alone, right here. I'm going to be consuming exactly, I'm getting excited. Can you tell? Here we go. I'm going to consume 3.5 units of x and 4.8 units of y. Can I afford this point? Can I get on a higher indifference curve and still afford a bundle? So this is the highest indifference curve I can possibly get on, given this budget constraint. All right, let me set up the intuition for next time here. What's the slope of the indifference curve? It's the marginal rate of substitution, right? So at this point, right here, I have some sort of marginal rate of substitution at this bundle, which changes along the indifference curve. But there's some slope of this indifference curve. What about the slope of the budget constraint? It's just the slope of the budget constraint. It's the marginal rate of transformation at that point. Well, what do you think is true for the marginal rate of substitution and the marginal rate of transformation, the rate at which you're willing to substitute between 2 goods and the rate at which the vendor of y and x is allowing you to transform them into each other? What do you think is true about the 2? They're the same. Your willingness, right, at the highest point at the sort of blitz point right here, given the scarcity you face, your willingness to trade between 2 goods is exactly equal to the rate at which the market lets you trade them off for another. I'm going to show you next time that this is equivalent to saying spending $1 on either good x or good y is going to give you the exact same amount of marginal utility, so you have no incentive to move away from this point. I will see you on Tuesday. There will be a problem set on the website. Have a nice, safe weekend, and I hope it rains.